All right. Hey, adventurers. Welcome to video 2 for floor 8. In the first video, we built or wrote the add child method, count from, and height from. The tree now builds and measures. Our self-test tree phases 2 through 4 are all green, and our taxonomy command prints the full outline for our bestiary. Today, we'll have two ways to walk the tree. We'll have pre-order into, which is going to be a depth-first recursive way to walk the tree, which will green up phase 5 in our self-test. And then we're going to have the level order option, which is going to be breadth first, which is going to be the one non-recursive method, which uses floor 7, which uses the floor 7 queue. And then that will make phase 6 green for us. The whole point today is the contrast. The same tree yields two different orders. And the only difference in the code, what we're looking at today, is really recursion, which is a call stack you can't see, versus a queue, which is bookkeeping that you can. And then I think it's going to be really helpful just to kind of be able to see that contrast there. Okay. So like I said, Monday's work, or the first video's work, is green. The tree builds, counts, and measures, but we can't yet list it. Phase 5 and 6 want two different walk orders, and both are stubbed for now. So today we're going to write them, and the difference between them is going to be our lesson. So let's open our hero and then go to our tree header file. Okay. Now, as we're thinking through this, one tree, two different ways to walk it. Depth first, remember, will dive down a branch before moving sideways. Okay. So if you go down, it'll go down and then it'll come back up. So a parent always comes right before its descendants. So that's going to be our pre-order method. When we think about breadth first, it's going to sweep one whole level before it moves on to the next level. Okay, so when we think about this, it's going to be the same nodes, same edges connecting the nodes, but we're going to have two different answers to the question of who comes next. And in code, the only difference is going to be how we remember where to go next. Depth first lets the call stack remember for you, i.e. recursion. Breadth first is going to be you remember, okay, in a queue, which is going to be the one that we built in the last module. And so we're going to build both just to flex our powers here a little bit. Right? We're dungeon crawling. We need to make sure our mana is high enough that we can rock and roll here. So let's go ahead and get into our. This should be pre-order into. Should be the method. There we go. We want the static void here. Okay. So with what we have here, we have a pointer to a node in. You notice we have a standard vector of type T here. We have a reference to that called out. Okay, we're going to use those two. So we'll say if in is equivalent to null pointer. That's our guard there. We'll return. Otherwise, we'll say out.push back. We'll access the data from in. And then I'll say for standard size T of I is equal to 0. I less than in, access the children size. And then I'll say plus I. What am I doing? Back up. There we go. Open our brackets up. And then I will say pre-order into. Perfect. In will access the children at the ith index. And then we'll say out. Okay, and that should be all we need to do for this method here. Now, this essentially is the same skeleton we saw in the first video. We have a base case for null, we loop over the children, and the act on this node type of situation is going to be our pushback yet again here. The order of these two is the whole game. We push the node first, then we recurse into the children, node before its subtrees. This is what makes it a pre-order type of setup. Notice this is the exact recursion that the indented taxonomy printer already does. Pre-order is that outline in that case. It's just flattened into a list. Okay. Now, one other thing here. Now watch how little separates the traversal orders. If I move the pushback after the loop, so if I said for standard size ti is equal to 0, if we keep this all the same here, and if I did it like this, so if I moved it outside, for example, if I wanted to do something like this, let's say I moved it here. Okay, so we did base case, we then loop, and then we push back. Now every node is recorded after its children. Yikes. That's post order, and that's not what we want to do right here, right? So the leaves print before their parents. One line moved. If we wanted to go ahead and do this, see, I could run this and build this executable here. Let me show you something here. Okay. It take us just a second. Okay, and you notice here we have a couple options here, or flags for our taxonomy command here. If I was to run taxonomy DFS, okay, you'll notice this is our depth first search. Now notice if I ran taxonomy with the DFS flag here, as I just did, we'd see the skeleton and the lich appear before the word undead. Notice we have skeleton, lich, right? So first is skeleton, second is lich. And you notice here that undead appears down here. What in the world, right? So we're kind of out of order here, right? The parents are showing up before the parents there. The children are showing up before the parents, sorry. So let's then go ahead and let's put this back, right? Because we want to make it to where we have the node first, then the children. So I'll put this thing back to be right after our guard. We then rebuild our executable again. Do our DFS. And then now you notice we have creatures of the hold, undead, corporeal, skeleton, right? And so you see now we're kind of back in the order we were supposed to be in, okay? So you notice there's just a small change in the code can change how it's displayed, okay? All right, so let's now go and do our level order command here. Not that one. I need to find. Oh, nope, not down there. Up here, I need to find level order. Here we go. Okay. Perfect. So we will keep. For this one, we have our level order. This will be constant. We have a standard vector called out. What we'll do it after this, say if the root is equivalent to our null pointer, we'll return out. Right, so that's our guard. I'll then say Q. I'll have a pointer there, a node called Q. And then I'll say Q.enqueue. And we'll enqueue our root. And then I'll say while not Q.empty. So while we're not empty. Okay. And we'll break down into this loop here. And I'll say node star current. So we have ourselves a pointer here. So our current is going to be equal to, we're at the front, so Q.front. And then I'll say Q.dequeue. Okay. And then I'll say out.pushback. And then here I will say the current, and I'll access the data there at current. And then I'll say for standard size ti is equal to 0, I less than the current, access the children's size. And then, of course, we'll do our plus I. And inside that for loop, I'm going to say Q.enqueue, and we will enqueue, and we're going to access our current children at the ith index here. As such, step out of that while loop. After the while loop, we will return out, which is going to be, we'll return that vector there. So what are we saying here? This is the one method on this floor with no recursion, okay? And it's really the promise from floor 7 coming due here. We enqueue the root, we then loop. We dequeue a node, record it, and enqueue its children. That's it. Now, why does this work? Well, the queue holds nodes in the exact order we'll visit them, okay? And because it's first in, first out, a node's children go to the back behind everything that's already waiting on the current level. So we finish a whole level before any of the next one comes out. Okay, so this is really closest first, guaranteed by the queue. The queue of type T that we built last week is the bookkeeping that makes the breadth first happen. Okay, so let's go ahead and let's build it. So I'm going to save this, build our executable here. Oh, probably forgot an arrow or something somewhere. Line 161. Okay, so close here. Let's see. Missing an underscore right here, I see. See if that fixes us up here. Yep, looks like that fixed us up. No problem. Okay. So we'll go ahead and get our commands going here. And what I want to do first of all is do our self-test on our tree. And now 1, 2, 3, 4, 5, 6. So 5 and 6 now. So our pre-order and level order are good. So you notice here our pre-order 1, 2, 5, 6, 3, 4, 7. So depth first search, and then of course 1, 2, 3, 4, 5, 6, 7. Breadth first search works good. Okay. We still have a fail on our last one, which is okay. We'll fix that in the next one. Not a big deal at all. So that's looking good. So essentially, phases 5 and 6 now are green. Okay, so pre-order gives the correct order. Level order gives the correct one. The search, which is going to be phase 7, will be in the last video. I also want to check out our depth first search here. Okay, so we see that. We have the creatures of the hold, undead, corporeal, skeleton, necrothal, lich. Okay, and then now let's try out the breadth first search flag. Okay, so you notice here, instead before we went creatures of the void, undead, corporeal, skeleton, kind of going down that way, right? Lich, incorporeal, wraith. So you kind of notice here we go from corporeal, right? We then grab these guys, and then we go incorporeal, grab these guys. We have the beast, then mammals, right? And then we go down the list there. Meanwhile, with the breadth first, you'll notice we have creatures of the hold, undead, beast, vermin, constructs, corporeal, incorporeal, mammals, giants, bone spider, rat king. So you notice the ordering there is different. Okay, so depth first dives for us. Creatures, then undead, then straight down into corporeal, skeleton, necrothal, lich. Right, so we go down into those. Okay, so a category immediately followed by everything filed under it. That's the intended outline flattened. Breadth first, on the other hand, though, if we look at this one, it does a sweeping motion. We have creatures, then the whole top row, undead, beasts, vermin, constructs, and only then the row below. Now, watch one node here. We'll notice undead is second in both walks. Notice we have undead here, and then undead is second in both of those, okay? And so that might get tricky, but notice here, skeleton is fourth on depth first. Okay, let me go back up here. Fourth, right here on depth first. Okay. And it's all the way down, what is it, like 14th on this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 14th in the breadth first search. Okay. So same tree, same code shape. One used recursion, one used our queue, and the order was different there. Choosing the walk is choosing the order. Okay, so go ahead, you can commit this code, and we can now build, measure, and walk the tree in 2 ways. In the next video, we're going to ask it a question. Find a creature and trace its lineage back to the root. Sounds pretty exciting to me. All right, I'll see y'all there. Bye-bye.